Good afternoon, everybody. Thank you so much for coming out. I really wanted to thank all the hosts for hosting me. I really couldn't have made it out here without them. They're not here right now, which is unfortunate, but thank them anyway, and thank them for organizing all of this for everybody. My name is Danny, and I'm one of the founders of BioBots. It's a pretty new startup. We've been around for about a year, and we build 3D bioprinters and bioinks. So these are devices that print three-dimensional living tissues. And just to clarify, since we're not in the US, we are based out of the US. We're actually a Philadelphia-based company, and we do business everywhere. So basically, over the past 12 months, we've shipped devices to all corners of the world. So it's been a really fast-growing business. The company was started by the team here at Play, if I can get it to go. Oh, too fast. It's me. I graduated from UPenn, like a year and a half ago. I studied computer science and biology. I had a lot of experience in microfabrication, built a lot of microfluidic devices, spent a lot of time doing genomics research and open source genetics. Our other founder and CTO, Ricardo, he's really the engineer here. He has a maker background, learned how to build 3D printers right as they were coming out, and really started the prototypes of what became our very first product. And after we started working together, we've been working together for a few months. We started looking around for people that were sort of more senior, that had a few more gray hairs, even though at this point I've got a few myself. And Tony Atala he's a director of the Institute for Regenerative Medicine at Wake Forest, and he actually came on our advisory board soon after we formed the company. He's one of the pioneers in this field of tissue engineering and 3D bioprinting. So the three of us together really is the backbone of what we do. And what we do, what BioBots does is, like I said, we build these devices, but really what we're about is we're about figuring out ways to help people build with life. So really design organisms and apply engineering principles to biology that will enable us to use biology and to use life as an engineering substrate, really control it and use it for our own purposes. And so what are those purposes? We've heard today a lot about this idea of regenerative medicine, or of using cells from a patient's own body to recreate tissues for patients and have them sort of incorporate back into the body. So that's definitely one of the things that we're motivated by. I actually just got an email from somebody this morning. I was on the train over here from Budapest, and it was this middle-aged guy. He emailed me saying that his brother had a really bad liver disease, and he was asking me if we could bioprint him a new liver. And unfortunately, we can't. It's really hard. And if that didn't come across in any of the previous talks, and just want to make it really clear, we're not at a point where we can bioprint any of these things and implant them into people. And that's exactly what we're trying to change by building great tools that people can really use. And some of the other things that motivate us are being able to use biology to discover new things. So discover cures for new diseases, discover new drugs, and really this idea of personalizing medicine, so being able to personalize drugs to individuals. Today we design drugs in these large and expensive clinical trials that aren't very targeted, and so you have one drug for a lot of people, for millions of people at a time, but every person is different. We all have different genetic material that, we're all different individuals. And so with bioprinting technology, we can begin to build systems that allow us to test drugs for individuals, and instead of having a drug that's developed for 1 million people, a drug that's developed for one person at a time. The main problem here, though, the thing that's been keeping us from achieving all of these great goals and all these great things that we'd like to do with biology, what's been keeping us is that the tools that we've had for doing biology for the past 100 or so years, although they've been great and they've been very powerful, they lack a few things. Number one, they aren't very modular. You need to basically, every time you have a new student, you have to teach them how to use pipette, teach them how to use all these different tools, and at the end of the day, they're running experiments, reading protocols. There's no automation here. So it's very far from what traditional engineering disciplines are like. And I show this picture because it's from 1905. Ross Granville Harrison was one of the guys who invented tissue culture. And this picture is showing him using some things that may look familiar. He's using a pipette. He's got a few petri dishes. And this is over 100 years ago. And really, I mean, like the quality of the photographs has changed, but not much more beyond that has changed. So we're still running experiments on two-dimensional tissue culture, these tissues that are 2D. And the tools that we're using haven't changed a whole lot. And what's the problem there? Well, I mean, we know that the body is this three-dimensional structure, and we're three-dimensional organisms, and cells really live in 3D space, not on flat petri dishes. So when we're running experiments on these model systems, they turn out to not be such great models. And so there's definitely been something that's been lacking that's stopping us from going from these 2D systems into 3D systems. And we know now, like back since the 80s, we've known that 3D systems, 3D tissue culture systems are much better. They're much better mimics of the human body. But really, there's three core technologies that we've identified that really need to change to be able to change the infrastructure of the way that we do biology today. And we do biology today fundamentally in 2D. I mean, most people. There are definitely, especially in this conference, a lot of people that are doing 3D tissue work, but it's definitely not the norm. And some of the tools we need to change are, first, is the fabrication technology. So we need tools that actually allow us to build three-dimensional living tissues in a repeatable, concise, easy-to-do way, effective, cost-effective. It's not gonna break the bank every time you run an experiment. And that you can design a protocol on your computer and share it with somebody halfway across the world, and they can run the exact same protocol without having to train a graduate student and spend many, many months teaching them how to use a pipette and quality control of their dishes and so on. And so the same goes for culture technology. There's actually, I love this picture. It's Oren Katz is a great bio designer, artist. I can't really figure out the best way to describe him, but I mean, yeah, we need bioreactors that can culture these 3D tissues. The way that we do it now in an incubator just it's not suitable for 3D tissues. And really the last thing that we need is imaging technology. I mean, our imaging technology and imaging infrastructure is really designed around 2D tissues. And we do have some tools for imaging 3D tissues, but they're fairly limited in scope compared to what they could be. And so what we did at BioBots was we started way at the beginning. We said, well, if we don't have fabrication technology, then we don't need any of the other things. So what we did was we designed what at the time was the first desktop 3D bioprinter. So this we launched back in December of last year. And it is basically Ricardo and I designed it in our dorm rooms at Penn. We started fundraising money to fund actually getting this thing out there, manufacturing it. We had some great investors back us, people who really believed not only in our vision and our idea, but actually thought that we could do this thing and actually get into the hands of people. So it's been amazing. I mean, the device, just to run you through some of basically what it does. It has a syringe, and there's actually one of these outside. So, and I'm probably going to be talking more about it tomorrow also. So I'm not going to get into too much of the tech here, but it's basically a syringe that lives in this cartridge that you fill with the material of your choice, and that material usually involves cells. So you've got a mixture of cells and biocompatible materials. And the key thing that we did was we developed a system that uses visible light to actually turn those materials from a liquid to a solid. And so you might ask, like, why visible light? Well, in the past, people had really focused on using UV radiation. And UV light harms cells. I mean, like when you go out into the sun, you usually put on suntan lotion or something so you don't get sunburned. And the same thing happens to these cells, and you fry them with UV radiation. That's the traditional process for 3D printing. So we developed a new one that uses visible light. It doesn't mutate the cells as much. And yeah, the device is otherwise a traditional 3D printer, so it moves in X, Y, and Z. And it goes around depositing material and curing it. And so this is how you can fabricate three-dimensional living tissues. And so our clients were able to build some pretty cool structures. I mean, we have a bunch of these awesome pictures. Obviously, this is not implantable. This is not going into a patient. And it is one material. So if you notice, the device only had one syringe or only one head. And the way that we started distributing this was we actually partnered off with some of the best researchers across the world. And they really were sort of all over. And these are just some of them. We partnered off with them for 12 months, or at least that was the original plan, was just to really give them as much love and support as possible. And they all have really amazing projects that I could spend an entire talk talking about. But suffice it to say that they worked across the spectrum of tumor biology to people who were really preclinical, people who were doing really early developmental stuff, just really spanning the entire spectrum of what was possible with this technology and really proving that 3D tissue culture wasn't something that just tissue engineers should do or could do, something that biologists and cell biologists, anybody working in biology in general should and could be doing. And we ran this beta program. I mean, I guess we only got to run it for around 9 months because we like to move really fast at BioBots. And what we did was we actually listened to these guys, listened to all of these researchers, listened to what they were doing, learned about the limitations of our devices, learned about what these people wanted to do and what they couldn't do on our devices, and what they were doing that they really loved. And we developed something new. And that is this device. We actually just launched it 3 weeks ago at the Termis World Congress, which is a tissue engineering and regenerative medicine congress in Boston. It's been amazing. I mean, these devices, we haven't even had one of them to play with since we had them because they just keep flying off. And it's got a bunch of improvements, fundamental, like, I mean, basically you can just tell it has 2 extruders. And so now people can do multiple materials at a time, which is just the next step. I mean, I'm not saying this is the best tool out there, but it is the most sophisticated desktop bioprinter that's ever been developed. And the key thing too that we do is we always try to keep the price of these devices low so that the barrier to entry really isn't that high. So that anybody, even if you don't have the full set of expertise, it's something that you can still decide to play with and develop the expertise if you have to. So this device is actually $10,000. That's US, and yeah, it's been a really exciting ride. And yeah, so I mean that's basically that concludes my talk. If you guys have any other questions, would love to take those now. Yeah, if, would like to learn more about the BioBot. I think I'm gonna give you another talk tomorrow, and I'll also be outside for a while today. So thank you. Yeah, so I mean, the system itself is, I mean, it's totally different design, but the basic technology, I mean, you're right, like we're both pushing stuff from like one place to another. The key thing that we do differently is that we use visible light to cure our tissues. Organovo doesn't. As a matter of fact, Organovo's printer focuses primarily on cell-free. Sorry, not cell-free. Just only cells, so they only print cells, no matrix. We actually think that using matrices, from what we've seen, is a lot more sophisticated and produces a lot better tissues. So our devices are optimized for printing very viscous gel solutions that have cells embedded inside of them. I mean, I forgot who it was that gave the encapsulation talk, but we really focus on printing those types of materials.
So I guess you have a very good feel about this technique and probably limit about the future as well. So do you see the chance that in the future you can actually print living tissue in a living body?
So I know that Tony at Wake Forest is a huge fan, and he works with James Yo over there, and they have a prototype of this really insane. I actually haven't been able to see it because it's like top secret, but it's like a big robot that it's like the size of a hospital bed, and they lay patients down on it, and I think they do print skin on them. I think it's all still, I don't think, none of it has been published yet, and I don't know how much of it is relevant, but yeah, I think it's, at least for simple things like skin, it's well, well, compared to, not vasculature things, that's what I mean. So as long as the tissues are